Good morning, students. I hope my screen is visible to you. So, a very quick recap. So, in the last class, I have discussed about exception handling. I have shown with demonstration how to use all the 5 keywords of exception handling, that is try, catch, finally, throw, throws. And also, we have seen with a program how we can create our own user defined exceptions, and then how we can use our own user defined exceptions from other application programs. All that we have seen with demonstration. And I said that in today's class we are going to cover wrapper classes and JUnit. So wrapper classes is very small topic. I'll just directly show you with demonstration. JUnit is one of the very important thing which you need to be familiar with. So first of all, what is wrapper classes? So for all the primitive data types, we have classes also. Like for int, we have integer class. For boolean, we have boolean class. For short, we have short class. For byte, we have byte class. For long, we have long class. For double, we have double class. For char, we have character class. So like this, for all 8 primitive data types, we have 8 inbuilt classes. And why these classes are meant for? These classes are meant for creating the objects for these data types, because we know that Java is object oriented programming language. So we require objects. We require objects. For that reason, we have for all 8 primitive data types 8 classes also. For all 8 primitive data types, you have 8 classes also. And this we call them as wrapper classes. And what is the purpose of this wrapper classes? In applications, we require in certain situations to convert primitive data types or primitive values to object type, and in some cases we require objects to be converted back to the primitive values. So when we create or when we deal with huge projects, there will be required situations where you need to convert your primitive types to the respective object types. Similarly, you might be having objects which you require to translate them to primitive types for your computation purpose. For such purpose, we will be using these wrapper classes. And from Java 5, that is J2SE 5 onwards, we have the concept of auto boxing and unboxing. We have the concepts called auto boxing and unboxing. It's only from Java 5 onwards. What is this auto boxing? So auto boxing is converting primitive type to object type. Auto boxing means converting primitive type to object type. And what is unboxing? It's just the vice versa. That is converting object type to primitive type. So before Java 5, it's mandatory by the programmer to write statement for converting this with some statements or some functions. With the use of some function only, this can be done before Java 5. But from Java 5 onwards, it is being provided automatically. This conversion of primitive to object or conversion of object to primitive is provided automatically. And as I said, since we are dealing with Java, which is an object oriented programming language, we require objects for interacting with collections. When we use collections, we require objects because collection is a group of objects. There, even though you have some primitive values, you require them to be converted to the corresponding objects in order to store or in order to organize with collections. And also, we require objects for serialization purpose, where we will be converting objects to streams. We will be converting objects to streams. Another application is we require objects for synchronization purposes. We require objects for synchronization purposes. That is, when we deal with multi-threading applications, we require this synchronization very much. So at that case also we require objects. For that reason, we make use of wrapper classes for converting primitive to object type or converting object to primitive type. For this purpose, we use this wrapper classes. And as I said, for all the 8 primitive data types, we have 8 inbuilt classes in Java which are useful for happening this conversion, that is primitive to object or vice versa. So very quickly, I'll just show you with the demonstration how to perform this conversion of primitive to object or object to primitive, and then I'll get started with JUnit. Now, so here let me just create a class. Okay, before that, let me use the magnifier. I think it will not be visible to you. So here is the so let me create a new class, and let's name this class as wrapper demo. So I just created a new class and named it as wrapper demo. And now, okay, let's create main method. Control space, and then here int a equal to some 10. Let me just write some int a equal to 10, and integer b equal to integer dot value of, here you can see the method value of, let us write a, and then so this is how you will be converting primitive to object. Now if you observe here, int a equal to 10, when I am writing, it's clearly evidencing that here a is primitive. That means here a is primitive type which is holding the value 10. But if I want to pass this particular, or if I want to store this value in a collection, can I do it directly? Definitely not, because collections will be storing only objects, and here a is a normal primitive value, so it cannot be stored inside a collection. So in order to have this stored inside a collection, you need to convert this to object. So here in the next statement you can see I'm using integer class. I'm using integer class, so it's not primitive type. So integer class b equal to integer dot value of, integer dot value of. Now to this value of I am passing the primitive value. So what happens is this value of is going to convert this particular primitive type to the corresponding class type, which is nothing but the object. So here b becomes the object now. So this is what we mean by converting primitive type to object type. And as I said, this we used to do it before Java 5 version, but now directly we can just do that like this. Here you can see, even if I am just writing integer c equal to small a, it's working fine. So there's nothing error. Now what is happening is, your compiler will implicitly write this particular statement internally. This particular integer dot value of will be written by your compiler, even though I'm just writing small a directly, but implicitly compiler will write this statement integer dot value of, and this we call it as auto boxing. This we call it as auto boxing. And even though I'm showing only for int, similarly you have for other primitive types also. Similarly, you can just try there with the long and write here long dot value of. You can just try with the double and you can see with the double dot value of. So it's all the same. So the point to be noted is converting primitive to object. We call that process as auto boxing. We call that process as auto boxing only from Java 5 onwards. Before Java 5, you have to write this statement explicitly in order to perform this conversion from primitive to object type. But from Java 5, you can directly use this statement. Simple. Implicitly, compiler will write this integer dot value of statement. You need not worry. So this is what we call auto boxing, which is the process of converting primitive to object type. Now, let me show you unboxing. That is opposite of auto boxing. So let me just create integer d equal to new integer of 20. Now here you can see d is object type. Now even though it is storing value 20, but you cannot directly perform some arithmetic operations since it's not in primitive type. So what you need to do is, in order to have some computations, you need to convert this back to primitive type. So for that, what you will be doing is int e equal to d dot, here you have, you can see the method int value which will return integer. You can just use this int value semicolon. Now here you can see what is happening. Now this d is object of integer class, and by executing this int value method, it will convert object to primitive type, and that you are storing it in primitive integer e. So this is what, how you convert object type to primitive type. This is how you convert object type to primitive type. And even I can write now like this. This is very simple. So now what I am doing, directly I am writing f equal to d. So again the same way, this is only possible from Java 5 onwards. Prior to that, you have to use these statements manually. So now this is what unboxing is. Here what is happening is, compiler again implicitly writes this statement d dot int value. Compiler implicitly writes this statement d dot int value. Similarly, the other types have their own methods: byte value, short value, long value, double value. Like this, the other classes have their own respective converting methods from object to the corresponding primitive type. So this is how you will be using wrapper classes in your applications for converting primitive to object and object to primitive. So converting primitive to object is auto boxing from Java 5 onwards. Converting object to primitive is unboxing again from Java 5 onwards. So this is what simply about wrapper classes. Now let's begin with the JUnit. So before getting into JUnit, first of all we need to understand what is JUnit and why do we require this JUnit. So Being technical students, I hope all of you have heard the term testing. All of you might have heard the term testing. You might have not applied it or used it, but you all might have heard the term testing. So what is testing? So testing is the process of validating your logic against some test cases. So you will be writing some logic, and then you want to test whether your logic works fine or not. For that purpose, you will be checking your logic against some test cases, which are nothing but you will give some input, and since you have written the logic, you know for what purpose you have written. So you also know what should be the output. So you will just trace it and see whether your logic works fine and gives the expected output. So this is what generally testing is all about, and you can do this in two ways. One is manual testing, the other one is automatic testing. So manual testing is nothing but you will write your logic on a paper, and then you will only give some input, you will trace it on paper, and then you will get some value by computing that particular logic with the input given, and then you will cross check this evaluated value with the actual value, and if both matches, then you say that your logic is correct. This is what manual testing is all about. So the same thing, rather than doing it manually, you can make it automatic. You can make it automatic. So for making it automatic, Java have provided a framework, and that framework we are calling it as JUnit. This is what the simple theoretical part you just need to understand. So JUnit is nothing but a framework that is provided by Java for the developers to perform unit testing. To perform unit testing. This is what the theoretical concept of JUnit. So you just understand that JUnit is the framework which is provided by Java for the developers to perform unit testing. Now what is unit testing? It's very simple. Unit testing is nothing but the testing that you are going to perform on unit of code. The testing that you are going to perform on unit of code. This is what unit testing is all about. And this particular unit testing will be required by developers in order to test their code. So they will be writing some code. I mean, developers will be writing their code, but they need to test, or we can also use the term validate. They need to validate their code against possible test cases. So for that reason, what the developer has to do is he need to create some test cases. He need to create some test cases. So what is the test case? Again, a test case is going to be a code which will be used to check that the expected and the actual are equal or not. So again, a test case is going to be a small piece of code which will be used to check that the expected and the actual are going to be same or not. So for that reason, we will be creating test cases. And in my introduction video also I just mentioned that JUnit is very important, because whatever the company's logic building exercises you people are performing, and even you might have worked with the metal tool as part of your logic building hour plans, there also you might have seen on the left panel you will be having the question palette, and on the right panel you have the developer code environment where you will be writing your code, and then when you click on compile and run, you will be seeing some test cases being passed or failed. It will be showing now. So that all things can be created using this JUnit. Not only JUnit, you have some other tools also available in the market, but as part of basic understanding, we are just using with the JUnit. So JUnit is a framework that will be used to perform unit testing. This is the point to be noted. And yeah, in HackerRank is another example where you will be writing your code, and when you click on compile and run, you will be seeing some test cases. And if at all it fails, then also you can see which is fail and what is expected and what is actual. It will be telling you all that information this particular test cases will give you. And JUnit is one such framework that lets developer to perform unit testing in order to validate his logic against expected and actual values. And Java provided org.junit package. Java provided org.junit package that contains many interfaces and classes for performing this JUnit testing. So this is all the theoretical part you can just remember. And now let's get into implementation and see how it works. So what you will be doing is you can just create in same package both the actual file as well as the unit test case file, but in reality no company will encourage you to have this test case as well as the actual code in the same package. They will suggest you to create a new package for the actual code and a new package for the test cases. Just remember that point. But you can have both in the same. Again, I'm telling you can have both in the same. I'll just show you as example. Here I have my package. So let me just create a class. So I'm just using the same example given in the PBLapp. So let's name this as calc. I'm just naming this as calc and then clicking on finish. And in this calc, what we'll be doing is we'll just define two simple methods, public void. Okay, since we are running this example for test cases purpose, we will return value to the server kind int sum int a comma int b, and then here we know what we are supposed to return. So return a plus b. So I need not explain this class and method. You can easily understand. So I'm just creating a class calc and then I'm creating two methods. One is sum, the other one is sub. That is subtraction purpose. So it's very simple to understand. A calculator class that's containing two methods. You can add other methods as well for product and subtraction. It's all up to you. So like this we are creating, and then just save this. And now what we do is here just do right click for just making you understand that it's not difficult to create both in same package, but in real time just remember that your actual code should be in one package and your test cases should be in another package. And here you can see, rather than going for class, now I'm going for JUnit test case. When I right click and going to new, you can see list of options. Now there you can see JUnit test case. For suppose if you don't find this JUnit test case, what you just need to do is click on other, and there a window gets opened like this. Here you can just see Java. You can see like this options. Just expand this Java. There you can find JUnit. Expand that, and there you can see JUnit test case. We will come to this JUnit test suite shortly. Just understand that if you don't find in the right click options JUnit test case, go to other, then the window gets opened. There you expand Java, and there you find JUnit, there you expand JUnit, and there you select JUnit test case. This is how you will be doing. And then a window gets opened. There you will be giving your test class name. Always try to give name which will be easily understood. So here what I am doing is, since my class name is calc, and this particular test case I am creating for calc, what I'll do is I'll just name this as calc test. This is what the coding standards. This is what the coding standards, and the next topic which we are going to cover tomorrow or day after tomorrow will be that coding standards. So as part of coding standards, you should remember this. So when you are naming your classes or variables or methods, they should be understandable by everyone who sees the code. Nobody should again ask you what is this for, what is this for, like that. Accordingly, you should name your classes or variables or methods, all that. Since this is a test class, I'm just naming it as calc test. Thereby it will be understood that calc is the class for which you are creating this test case. So that's what. And let's not get into these things right now, and click on finish. And here you can see it will be asking, do you want to build the path? Because by default only JRE is being added to our package. Since we are creating a JUnit test case, we also need to add this JUnit library. And here you can see, since I am using the latest version, it is saying, do you want me to add JUnit 5 library to the build path? Because currently the build path contains only the JRE, that is Java Runtime Environment. But when you want to create test cases and test them, you require JUnit library. So if you are already installed the latest packages, then automatically you will be having. Otherwise what you need to do is, you need to download this jar. If you just type in Google junit.jar download, you can just get it. You can just download it and keep it in any place. And earlier I have shown you as part of Eclipse overview how to add jars. So you can just once again go through that video and see how to add external jars. And there you can select the jar which you downloaded from the internet and then add it to the build path. So this adding this JUnit framework is mandatory. If you already have it as part of the Eclipse installation, it will be there. But if you have some older versions and if it's not there, then what you are do, I'm just saying, you just need to type in Google JUnit jar download, and you can download it and keep it in some folder, and then right click on the project, and then what you can do is go to the properties and go to the build path and go to the add external jars, and then you can select the jar which you downloaded. Now what happened is, here you can see what happened. Can you see? I hope everyone can see. Since I have asked this IDE itself to add this JUnit 5, it have added to my project. Now JUnit, all these jars are added to my project. So now here, this is my calc test. So in my calc test you can see, so by default this is the structure it will be coming, and compulsory when you are performing a test case, you need to write this annotation @test. So here basically we will be using 6 of the annotations. The first one, the mostly used, is @test, and this indicates that it's not a normal method, it is a test case method. That's what it indicates. And this name can be anything. It need not be just test like this only. You can have any name, no problem. Let us delete this statement. It's just saying fail not yet implemented. So you can just see what happens if I just run. So if I just run this, nothing will happen. And when you go to run as, you don't find Java application, since this is a JUnit test case which you created. Here you can see JUnit test. When I just click on run, so here it is asking Okay, wrapper demo it is asking. Okay, anyway, even if you give, nothing will be coming there. Here you can see it's just saying fail because we haven't deleted that fail and we haven't even implemented anything. So actually this should be coming in always green color. If it is coming in brown, you should understand that it's not success. If this bar is not in green, just understand it's not success, whatever the test case you just implemented. Okay, anyway, let's get into the actual content. So just let us remove this code, and then what you will be doing is, so we have written methods in calc. So let's test that. So how you are going to test that is, in this test method what we will be doing is, we will just create object, and calc ob equal to new calc. So this is how you can just create object, and then we will be using a method called assert equals. Assert equals, and here you can see what it is saying: quick fixes. So if I give assert equals, you can just find in this int. Yeah, here you can see int expected and int actual. Here you can see int expected, int actual, like this you can see. So this one I am choosing, and then here you can see what is happening. Automatically the package got imported, and this I have discussed earlier, it's a static import. This is a static import, and this static import means you need not write here the class name before. I hope you remember in my previous session I have said you with the system.out.println, if we use import static java.lang.system.star, then instead of writing system.out.println, you can just use out.println. Similarly here also, actually what am I supposed to write is assert dot, because assert is the class which contains all these methods. So assert is a static class, and these are all static methods. So here directly I am using the method because I am using static import. Actually I haven't written this, since I have directly invoked the method by using the control space, and from the drop down list I have selected this method, so automatically it got added. But when you are going to write, you should write like this. So assert equals expected. So what we will do is, let's write some 9, and here instead of actual what we do is ob dot, what is the function, sum in the brackets 4 comma 5. So just understand this. So this assert equals will be taking two arguments. One is the expected argument, the other one is the actual argument. So the expected value and the actual value, and how you are getting the actual value? The actual value is returned from the sum function, which is in calc class, and we are passing the values 4 comma 5. So in the metal tool you might have seen, by default some test cases will be shown to you with inputs. So this is how it will be done. So here in the expected, we are saying what is the value that should be returned, and this is the actual returned value, and if this both matches, then it will be showing success, otherwise it will show fail there. So that's what the point need to be understood. So let's run this and see whether it's coming or not. Run as JUnit test, and now, yeah, here you can see green bar. Here you can see the green bar. So this is what you should understand now it is successful. This is success. Suppose here I'll just show you with the change. I'm just writing 8. Actually the correct answer is 9 only, but only to just make you understand. Now if I'm just writing 8 and run as JUnit test, now you can see you are getting brown. So if you get green it is success, if you are getting brown you can understand it is failure. Here it is saying one failure, and here you can see the time taken 0.095 seconds. This is the time taken, and if you go down here you can see, I hope this is visible. Here expected is 8 but the return was 9. So this is what you can see even in the uh, logic building problems where you will be doing. So the expected is 8 but actually you are getting 9. I mean whatever the logic written by you, it is returning 9. I hope everyone can see this. Here it is saying assertion failed error, expected 8 but actually was 9. And here you can see the print stack trace. This is nothing but the print stack trace. So it is coming because of line number 12. It is coming because of line number 12, that is calc test.java. That is our own class test. So there, because of line number 12, this particular thing got. So this is how you just need to understand how to write this. And next, similarly, when you have multiple test things that you need to do, what you will be doing is, here rather than writing this test, we will be generally writing, for making it more understandable, uh, void test sum like this, and then here so I'm just pasting this, and instead of saying test sum I'm just writing test sub, that is for subtraction. And here I'll be writing 5, and here let's write 3, and subtraction should return 2. Okay, let's keep like this and once again check it. So it's working fine. Yeah, ob dot. Okay, here also I should write sub. This is for subtraction function which we have written in the calc program. So when I just click on this, run this, so it's not giving any error, only test sum is being run by this test. Okay, this is another point need to be understood. Here you can see it is saying only one is being run, and it is saying only test sum is being evaluated. Even though I made a mistake, this is a lesson for us. Here you can see this annotation is mandatory. This @test annotation is mandatory. Since I have ignored that annotation, that particular test is not being performed. So if you have written a method for performing test case, you must and should include this annotation. Since I have ignored it, you can just see it did not checked it. Now once again let's run this. So here you can see 2 of 2 were run and one failure. There is one failure, and here you can see the tick mark for test sum and the cross mark for test sub. So the test sum got successfully validated but the test sub failed. And again when I go down, here I can see failure, expected 9 but was 2, expected 9 but was 2. Here this is the reason. So actually the correct value is 2 only, because I have given 5 and 3. So I just changed it. Now once again when I just run this, here you can see no failure trans and the green bar. When I expand this you can see, so for test sub it took 0.08 seconds, and for test sum it took 0.028 seconds. So this is what the time taken, and I think in few of the companies even they will enforce you with that particular timeout also. How you can just do that is, For your understanding, I'm just showing you what they will be writing is here at test of. They will be using this statement timeout equal to something like this 1. So here you can just go for the quick fixes. Rename only it's giving. So it's small t only actually. Once let's get to the theory. So actually timeout if we give means it indicates that within that time only your code should work. Just a second. Did you got to see the test annotation? Here test at the rate test only. But you can write at the rate test of timeout just to make sure that your logic will be executed or your computation will return the result within the stipulated time. Yeah, here you can see at the rate test timeout equal to 1000 if you specify like that. So what we are expecting is we are expecting that the result should be returned within this specified milliseconds. So here 1000 is the milliseconds. So within this specified time the result should be returned. Okay, I'll just check this later, but just remember this. If you specify the timeout, it indicates that the result should be returned within that specified time. So this is what the at the rate test with timeout. So the timeout field is used to make sure that the test result is being returned within the set milliseconds. So this is what the at the rate test is used for. And here you can see like this you can write any number of test cases, and if anything fails like what I have shown you, you can just get that. So here you can see test sub, test sum, like this it will be returning all the tests that it have performed, and if any failures in the bottom failure trans you will get what was expected and what was returned, all such information you will be getting that. And now you just need to remember that not only single test class like this, you can create multiple test classes also. Suppose if I am having here calc, now let's again go to package explorer, and then if I go here to talent new class, let's make one more class calc1, and finish. So what I'll do is in calc1 also I'll just add two more methods. I'm just trying to explain you this test suite, how to create a test suite. What is test suite is grouping multiple test cases. Right now we have created only one calc test class now. Like that we can have multiple test classes and grouping all these multiple test classes under one single group, we call that as test suite. That's what we call test suite. And here I'll just for multiplication and division I'm just writing, and here I'm just replacing with multiplication and division, and then let's save this. And then what we do is one more test class we will create. So JUnit test case. So this is calc1 test. So this is calc1 test, and here again what I do is from calc test I'll just take this code, and then calc1 test I'll just replace this, but instead of this test sum, what we'll do is test mul. This is for multiplication purpose, and this is for test division. And here instead of calc, let's create object for calc1, and then here it should be ob.mul, and 4 5s you should get 20. And similarly here this is for calc1 again, and then here let me use 6. So 6 by 3 anyway 2, and here instead of sub we will use div. So I hope everyone understood what is that I have just done. So what I have done is similar to calc and calc test, I just created one more for calc1 and another calc1 test. In that I have just created test cases for this calc1 multiplication and division. And let's first run this and see if everything is fine. So it's fine. When I expand this, yeah, it's saying test div and test mul, so it's working fine. Now the point which I'm trying to tell you is we can even create a test suite. For creating a test suite, what you will be doing is you just right click on the package where you have these test cases and go to new, and then instead of going to JUnit test case, go to other, and there here you can see other than JUnit test case there is one more thing, JUnit test suite. There is JUnit test suite. Click that JUnit test suite. Next, and there you can have the test classes included. Here it's not showing any test classes. Okay, what we do is generally, as I said, in real time what you need to have is the test classes separately you need to have in the another package. Right now what I have done is I have all my normal classes and this test classes also in the same na. So here this is the place what you where you need to do. This is how the test suite will be created, and then what you will be doing is in this suite classes you are going to write all the test classes. You are going to write all the test classes. That is whatever the test classes right now we have created. That is calc.test class, calc test class. So you have to write the class. So this is how you have to write calc test.class, comma other classes also you can just add like this, calc1 test dot class. So like this comma separated you can add all the test classes. Suppose if you have in separate package these test classes, then automatically when I have created the test suite and clicked on next, it will be showing me all the test classes separately. It will be showing me all the test classes separately. Since I have written everything in single package, it's not showing me separately. That's the reason manually I'm supposed to rewrite all this. Comma separated test classes you have included in the suit classes. Now here you can see it runs with suit.class. It runs with suit.class. And here you can also just include this suit classes. Because here you are saying suit.class. What is that suit it's containing? It's containing multiple classes. And what are those test classes it is containing is calci test and calci1 test. So this is how you will be doing. So this is how you will be creating a test suite. The advantage with the test suite is rather than running individual test classes separately, you can just keep all these test classes in a single test suite and you can just invoke this test suite at a time. When you invoke this test suite at a time, then all the test classes will be run. That's the advantage by going to this test suite. So you can see all tests being run and it is saying green color. So this is how you will be using the test suite for grouping up multiple test classes. So let's get to some theory, and here you can just use few annotations. These annotations are very simple to understand. You have annotations like at the rate before, at the rate after. You can just try this. If you write this at the rate before, then what happens is for each test case invoked by you, this particular at the rate before method will be executed for every test case. For every test case that you write, at the rate before method will be invoked. Similarly, at the rate after will be invoked after the test case is processed. That's what the at the rate after annotation. And these method names can be anything. It's not mandatory that you need to have like this before and after only as the methods. You can have any other method names also. That doesn't matter. And similarly here also you can see these method names can be anything, but in general, as I said, for making the code understandable by everyone, we will be using these names like this only, because it will be easily understood for those who see your code. Similar to this at the rate before and at the rate after, we also have annotations like at the rate before class and at the rate after class, with the only difference that at the rate before will be invoked with each test case processing, whereas at the rate before class and at the rate after class will be invoked exactly once. They will be invoked exactly once. I repeat, the basic annotations that we use will be 6 of the annotations: at the rate test, at the rate test of, in the brackets timeout equal to 1000, which indicates that the result should be returned within the set milliseconds, and at the rate before class, at the rate after class, which will be invoked only once, that is before starting all the tests and after completing all the tests. So at the rate before class will be invoked before starting any test. At the rate after class will be invoked after completing all tests. Next, at the rate before annotation will be invoked before each test. At the rate after annotation will be invoked after each test. So these are the 6 basic annotations that should be remembered, and as part of this material also you can see the same 6 annotations. At the rate test, which will be specified that a method is not a normal method but it is a test method. Similarly, at the rate test of timeout equal to 1000 or something, if you are specifying, it will be returning fail if that result takes longer than this set milliseconds. At the rate before class, which will be invoked only once before starting any test. At the rate after class will also be invoked only once after completing all tests. At the rate before annotation will be used to execute before each test. Before performing each test case, it will be invoked. At the rate after will be invoked after each test case. So these are the 6 annotations that will be required for performing JUnit, and this which we are using is from 4 version onwards, that is JUnit 4 version onwards. It's purely annotation based, and JUnit 5 is also almost ready. It's with the lambdas, which is more powerful. Let's not get into those details. And also methods were also given here. After, yeah, here you can see one more annotation, but rarely we use this at the rate ignore in order to ignore a particular test case. Whichever test cases you want to ignore, those things we just use it with at the rate ignore. And next, so methods also are important here. Yeah, here you can see the assert methods, and all these assert methods are part of this assert class, and all these are static methods. Just remember this, all these methods are static methods. Here you can see again the same thing, static import. Since we are using static import, you don't require to mention the class name before calling the method also, since we have done the static import. So this is the purpose of static import, which we have also discussed in previous sessions. And here you can see one of the assertion error that you can get. Here the method is long. Whatever I have shown you is a integer method. If the method is long and if you directly write like this, by default it will be considered as integer, but the expected is in long. So that's the reason here you can see a lang assertion error will be erased. So what are the assert methods that are present in assert class are? These are the basic assert methods, and mostly we will be using assert equals, assert true, assert false, assert null, assert not null. These are the 5 assert methods that will be used by any developer in real time. So assert equals method will check if 2 primitives or objects are equal or not. Earlier I have shown you na assert control space, when I have given, you have seen so many assert equals methods na. So there you can see 2 of the values will be there. They can be primitive object, object primitive, 2 primitives, 2 objects with combinations of 8 values, 8 types, that is int, short, byte, long, boolean, char, and double, float, all those 8. So with the combinations, you can just see with combinations you will be finding there with the 2 of the primitives, with the 2 of the objects, with 1 primitive and 1 object. Like that you can see multiple combinations there. So all that is possible with assert equals method. So the main purpose of assert equals method is to check whether the 2 primitives or objects that are passed as arguments are equal or not. And the first argument is going to be the expected argument, and the second argument is going to be the actual argument. So the expected and actual, if they are equal, then you will be getting success, else you will be getting failure. And failure description also will be given, indicating the expected value and the actual value. That is what the purpose of the assert equals method. Next, coming to assert true. Assert true method is a condition which checks for true value. Assert true method is a condition which checks for true value. Similarly, assert false will be returning true if the checked condition is false. Assert false will be returning true if the checked condition is false. That means you are checking for something false, and if it is correctly false, then you will get success. That's what the thing. Next, assert null is used to test an object. Here in this description you can see it is used to test a variable, but it's not a normal variable, it's a object reference variable. That's what the point to be noted. So it is used to test a object if it is set to null or not null. So if it is null, assert null function returns true, that means success. If it is not null, assert not null function will return true. So it's basically to test whether the object is set to null or not null. That's what this assert null and assert not null methods are useful for. And as I said, rest of the methods are optional in mostly, not mostly, almost in all the projects that we develop. As I said, we use the 6 annotations and 5 static methods of this assert class. The 6 annotations that we will be using are @test, @test of timeout, @before class, @after class, @before, @after. And the 5 assert methods that we will be using mostly are void assert equals, void assert true, void assert false, void assert null, void assert not null. So as you can see, assert equals will take two values, expected and actual, and checks whether they are equal. That is, expected and actual are equal or not. Next, assert true and assert false takes condition as argument, and then they return true if the past condition is true or false. Similarly, assert null and assert not null both takes one single argument, that is the object argument. That's what here you can see, test class dot get object. So assert null and assert not null both takes object as the argument and checks if the object is set to null or not null. And rest of the asserts are optional, assert same and assert not same. What you can see here, they are used to check for whether the two references are same or not. So that's what this assertions. And these are the things that we'll be using. Yeah, and test suite I have just shown you now how to create test suite. So in the test suite, basically we will be using only these two annotations, which I have shown you in the Eclipse IDE also, at runs with and suite. So here you can see the same thing. What I have just created two classes now. The same thing here you can see the same calc, and here you can see at run with suite dot class and @suite dot suite classes, which I have written there. And these are the two classes in this particular material that were shown, which were added to the test suite. And as I said, in reality, what we'll be doing is we will create a separate package exclusively for this test cases classes and the test suite classes. We will not be combining all the regular classes and test case classes in one single package. Just for demonstrating you, I just kept everything in my talent package only, which I'm using for explaining you all these days. But in reality, what you will be doing is your regular classes will be in a separate package, whereas your test case classes will be in a separate package. So you can just try with creating a new package and writing your test case classes there, and then you can just right click on the package and then go to new and then go to other and then expand Java and then expand JUnit and then select test case suite, and then after choosing JUnit test suite, you can just click on next, and there you can see all the test case classes that were there in that package. You can then select the checkboxes accordingly, which of the test classes you want to group them under this test suite, and automatically this will be created. Like this, will you can just see it automatically gets created, where whatever the checkbox selections you made, all those test cases will be grouped under that suite. So that is what the test suite is all about. So you can just check if any of the test cases pass or fail there. So in this quizzes I need not discuss because answers were given there itself. In all these quizzes answers were given there itself. And the home page did not get opened. So I think tomorrow's class will be on collections. We are done with the wrapper classes and then the JUnit. So we understood wrapper classes purpose is to convert primitive to object and object to primitive, and JUnit purpose is to create test cases to validate the code that was written by us. I mean the developer. So this is about today's agenda, and tomorrow's class will be on collections. We are not going to cover all the collections. I'll just cover the required collection set for this particular training purpose, and rest of the collections can be explored by you. And if time permits, I will also introduce you to streams, that is IO streams. Basically we will see what are the different types of streams, character streams, and this byte streams we have. So we will see how these character streams and byte streams are useful with some simple examples I'll demonstrate you. So that's what tomorrow's agenda. So let's wind up for today. So just post your queries if any in comment section, or directly give your attendance in the comment section. So I hope all of you have given your attendance and I don't see any queries. So let's wind up today's session and meet tomorrow's class for discussing collections and streams. Thank you.